So guys, now what next? So now we have thread execution data object available and it has all the information contained within it. Now the next thing that we need to do is to trigger this thread. That is, make this thread execute, right? And this thread must execute stage 2 first, followed by stage 3. So now it's a time to allocate a thread function to be executed by this thread, right? So what I will going to do is that I will assign a function to this thread. Now you must be wondering what is this function is. We have not seen this function before. We will going to discuss the implementation of this function shortly, but as the name suggests, this function takes the responsibility to execute stage 2 first, followed by stage 3, right? And it is this thread which will start its execution by invoking this function, right? So this is actually a high level function which encapsulates the execution of stage 2 followed by stage 3. And the argument to this thread data structure is nothing but it is thread execution data, right? So now that we have thread function as well as the thread data on which the thread function has to operate on, we can now trigger the execution of this thread. And for that we will use the second helper API thread pool run thread, right? So whenever we have thread function as well as thread data available, we can always trigger the execution of the thread. So this thread will now start its execution with this function thread function execute stage 2 stage 3. So as soon as this API is invoked, this thread would start the execution of its execution flow with this function, right? And this function accepts an argument which is nothing but this thread execution data. So now let us discuss the final piece of this thread pooling design, and that is the implementation of this API thread function execute stage 2 and stage 3. So back to the slide, this API is all about executing the stage 2 and stage 3. And the argument to this API is nothing but the thread execution data, right? And the thread execution data has complete information regarding how to execute the stage 2. So now it's a time for us to actually trigger the stage 2 execution. And stage 2 execution can be triggered as follows, right? Simply invoke the stage 2 function with the stage 2 data, right? And when this function returns, it means that the stage 2 execution has been finished and it's a time to actually execute the stage 3. And stage 3 can also be executed in the same way. Invoke the stage 3 function through a function pointer and pass the thread pool and the thread itself, because these are the arguments which are expected by the stage 3 API. We already know this, right? Now if I ask you one question, would the thread ever come out of this function? Would this function ever execute to completion? The answer is no. This is because in stage 3 the thread would going to park itself in the thread pool and would going to block, right? So it means that the execution control would never going to come here, right? Because the thread would have blocked in this function itself. Now the final thing is that we need to execute this API in an infinite loop. This is because when the thread executes the stage 3, the thread would block itself and we will signal the thread to resume its execution to perform another task which is provided by the application. Meaning that when the thread has parked itself into the thread pool, the thread will be fetched from the thread pool and signaled only when the application has changed this thread stage 2 function as well as this stage 2 argument with some other function and other data, because the application would want to reuse the same thread again and again to perform different types of tasks, right? So whenever a thread is given a signal, the thread will come out of this stage 3 function, right? And because of this while one loop, it will go to the stage 2 again and it will again block itself to the stage 3. and the cycle will keep on repeating, right? At no point we are destroying the thread or creating the thread. After using the thread, we park the thread to the thread pool, right? And when the application wants to reuse the thread again, the application simply fetches the thread from the thread pool, changes the binding of the stage2 function with another function pointer, as well as change this thread stage2 argument data and signal the thread, right? So what I will do, I will simply copy paste this function into our code. And with this, we complete the implementation of thread pooling. I have tried to be as elaborative as possible so that you guys catch up the design of thread pooling, because the rest of the data structures that I will going to discuss in this course are even more complicated. So now that we have completed the code, now we will write a small program which exercises this thread pool APIs or data structure and see how thread pooling helps the application to accomplish its task.